Hello everyone, I welcome you all to this class. This is mathematics class and we are here again to consider another important topic, integration by partial fraction. So we can use partial fraction here because the degree of the numerator is smaller than the degree of the denominator. So what do? We factorize that expression, right? To factorize it. Solution, integral of x divided by x squared plus 4x minus 5 dx is equals to integral of x divided by, we can factorize this, right? Now we are having the constant term is what? Negative 5. Negative 5 multiply the coefficient of this x squared. Coefficient of x squared is 1. Negative 5 multiply 1, we have negative 5. So look for two factors of negative 5 such that their sum will give you this positive 4. That's the coefficient of the middle term. And the product will give you negative 5. Of course, we can think of these two factors to be positive 5 and then negative 1. Because positive 5 plus negative 1 will give you positive 4. And positive 5 multiplied by negative 1 will give you negative 5. So this will work. So quickly you are going to have what? X squared plus, so here now the middle term will take this, the coefficient of the middle term will take positive 5, so we have positive 5x. Then the other one will take what? Negative 1. Negative x minus 5 dx. So that's what we now have, dx. So you can do the simplification further. This is x divided by what is common here? X is common. Then x divide x squared, we have x. X divide the positive 5x, we have 5. Then what is common here is negative 1. So I can factor that negative. Then I have x plus 5 dx. And then this is integral x divided by, we are done with factorization. We pick this coefficient of this bracket and this coefficient of this bracket and form a bracket, that x minus 1. Then we pick any of these common brackets, x plus 5. We have factorized this dx. So what's the next thing is to use partial fraction. So we split this into partial fraction. In case if you want to perform an integration and the denominator is already factorized like this, you notice that the degree of the denominator will be bigger than that of the numerator, you can use partial fraction and to do the integration. Let's consider this thing. Now we want to consider now x over x minus 1 multiplying x plus 5 equals, so we want to split this fraction now. We want to split it into partial fraction. So the first factor here, you are going to do a over the first factor, x minus 1, plus b over the second linear factor, x plus 5. So this implies if you multiply both sides by this denominator, so you will have what? X here equals to, multiply this fraction by this denominator, this will cancel this, remaining what? This quantity multiplying a, so I have a into x plus 5 plus this denominator multiply this last fraction, this quantity will cancel this quantity, remaining this one multiplying b, we have x minus 1 multiplying b. So we are going to use elimination method. Elimination method is just trying to try to make one constant to be 0 so that you can solve for the other one. So we want to get our a and b, right? So we can make if you want to make b to be 0, what will you do? If x becomes 1, this b will go 0. So we can say let x be equals to 1. This implies, so we'll put 1 here. We now have a into 1 plus 5 is what? With 6. So we'll be having 6a. And of course, if you put 1 here, the b will go 0. So we can solve for a. So this implies that a is equal to, if you make a the subject here, 1 over 6. 1 over 6. So now we have gotten our a. So next is to get our b. If you want to get your b, you try to eliminate a so that you can get b. So how do I eliminate a? If x becomes negative 5, I will eliminate a. So I will say let x equals to negative 5. So this implies, so anywhere you see x, you put negative 5. Put negative 5 here, you have negative 5 equals to, put negative 5 here, a will go 0. Then you now have 0 plus, put negative 5 here. You'll be doing negative 5, negative 1, which will be negative 6 multiplying b. So this implies that negative 5 is equals to negative 6b. And this implies that b is equal to, divide both sides by the coefficient of b by negative 6. You get that b is equal to negative 5 divided by negative 6. And of course, this is equals to positive 5 divided by 6, because negative will get cancelled, right? This implies that x over, open bracket, x minus 1, x plus 5 is equals to, what do we get for our a? Our a is 1 over 6 dividing 1 over 6 divided by x minus 1, plus the second one is gave us 5 over 6 divided by x plus 5. So we have splintered it into partial fraction. So therefore, integral of x divided by x minus 1, x plus 5 with respect to x is equals to integral. So the integration of this quantity is same as integration of these two fractions. So because we have splitted this fraction into this partial fraction, so we now have 1 over 6 divided by x minus 1 plus 5 over 6 divided by x plus 5. So this is what we have with respect to x, dx. So what I've just written down now is that I pass this integral to each of them. Now 1 over 6 is a constant, right? It can come out of the integration, so that this will be equal to 1 over 6 integral of 1 over x minus 1 plus, okay, with respect to x, plus 5 over 6 can come out. We have 5 over 6 integral of 1 over x plus 5 with respect to x. So that's what we now have. Though, look at this fraction you have. What is your denominator? Your denominator is x minus 1. Differentiate x minus 1 with respect to x. Of course, if you differentiate negative 1, you get 0. If you differentiate x, you get 1. And this is exactly what you have at the numerator, because what you have at the numerator is 1. So the result of this integration is simply the ln of the denominator. So this is 1 over 6 ln x minus 1. Right? That's what we have. Then plus this one too. If you differentiate what you have at the denominator, we have x plus 5. If you differentiate 5 with respect to x, you get 0 because 5 is a constant. If you differentiate x with respect to x, you get 1, which is exactly what you have at the numerator. So the result of this integral is the ln of the denominator. So we have 5. So we have 5 over 6 ln x plus 5. Of course, we have to put what? The constant of integration plus c. So thank you so much for being part of this class. We are going to solve more examples on this topic. So I'm expecting you in our upcoming class. Bye.